Metric sequences. We've previously looked at an arithmetic sequence where one term to the next you're adding or subtracting the common difference. Geometric sequences, from one term to the next you are multiplying by a fixed amount called the common ratio. So in this sequence here we are multiplying by 3 to get from one term to the next. In this sequence here, it looks like we're dividing by 2, but we only ever talk about it in terms of multiplication. Dividing by 2 is the same as multiplying by a half. So here, my common ratio is a half. So a geometric sequence is formed by multiplying the previous term by a fixed number. So fixed just means the same in the entire sequence. Called the common ratio. Now the common ratio is R, and you'll remember that we got the common difference by doing each term minus the term before it. The common ratio is each term divided by the term before it. T2 divided by T1, which is the same as T3 divided by T2, which is the same as T4 divided by T3. So here, 6 divided by 2 is 3. 18 divided by 6 is 3. 54 divided by 18 is 3. So you divide the term by the term before it to find the common ratio. Now you'll notice in these two examples that when the common ratio is more than 1, my sequence increases. So I'm multiplying it by a number greater than 1, so the numbers are getting bigger. When my common ratio is between 0 and 1, the sequence decreases. So I'm multiplying by a number less than 1, so it's becoming smaller. I'm multiplying by a fraction. Now, we're only dealing with a common ratio of more than 0 in this. Common ratio is greater than 0. You can have negative common ratios, but at the moment we're not dealing with that. But if it's a number bigger than 1, you're multiplying by a number more than 1, you get larger numbers. Multiplying by a fraction less than 1, smaller numbers. The way we'd normally say R is between 0 and 1, we would write R is less than 0 and 0. I got it wrong. R is greater than 0 and less than 1. Sorry, it's late in the afternoon. This is just saying R is between 0 and 1. I'm just writing that mathematically. So if you see that, it means this. So, if you've got increasing terms, it'll rocket upwards. These will get closer and closer and closer to 0, but won't ever get there. We'll talk about that a little more later on, because I'm running out of time. So, to determine if a sequence is geometric, you'll remember to be geometric it must have a common ratio. So you must show that every term divided by the term before it equals the same amount. So here, the ratio is T2 over T1, which is 10 over 2, which is 5. The common ratio is T3 over T2, 50 over 10, which is 5. And the common ratio is also calculated by doing T4 over T3, 250 over 50. If you're not certain at any stage, do of course grab your calculator. 250 divided by 50, 5. So this has a common ratio of 5. So since it has a common ratio, the sequence is geometric. Checking this one, ratio is T2 over T1, 6 divided by 3, 2. The ratio can also be found by T3 over T2, 18 divided by 6, that equals 3. There's not a common ratio. You don't even need to check the next one because these two are different. There is no common ratio. Therefore, the sequence is not geometric. So that's how you tell if a sequence is geometric. You must show that every pair of numbers and the number before it gives the same ratio. And that's also how you calculate the common ratio. Now we'd also need to look at geometric sequences in terms of recurrence relationships. So for this rule, for the sequence generated by this rule, find the first term, the common ratio, and the fourth term. So the first term, T1, is 7. That's nice and easy, they told us. The common ratio is found in the rule. Every term is gained by doing the term before it times a number. So my common ratio here is 2. And for term 4, you just generate that recursively. 7, I don't have a graphics calculator, someone's borrowed mine. 7 times 2 times 2 times 2, we've got to term 4, T4 equals 56. Now at this point, I realize that what I haven't told you is the form of a geometric sequence, which would have been really helpful here. Because the form of any geometric sequence is term 1 is A, that is, it's the first term, and the next term along is generated by the common ratio times the previous term. Sorry that I did not write out the form of a geometric sequence before hitting you with that question, but I'm sure you can see that the common ratio is multiplied by the previous term to give you the next term. This is the form of a geometric sequence, the ratio times the previous term. My bad. And using that, we need to be able to write a recurrence relation for this sequence. So of course we need to know the first term and the common ratio. They haven't told me it's a geometric sequence, so I will have to check. So I have to show that this has a common ratio. Term 2 divided by term 1 is 3072 divided by 768. And check that the next one is a common ratio, T3 over T2. Guess what I just did wrong? I did term 1 over term 2. I was meant to do term 2 over term 1. 3072. Oh, I did it again. It's not my day. 768 over 3072 equals 1/4. There's McClintock. 192 over 768 equals, this had better be 1/4. Yes, it is. Good. I'm sorry, we've found the common ratio. You write the form. T1 equals A. Tn plus 1 equals R times Tn. And then we substitute in our first term and our ratio. T1 is 3072. Tn plus 1 is 1/4 times Tn. So you're just substituting in to make the rule for this recurrence relationship of a geometric sequence.